Okay, welcome to week 6, part 1. We know how to create collections of numeric values with lists or NumPy ND arrays or with data frames with columns of numbers and so on. In this next material, we're going to take a look at matploilib, which gives us a very powerful and very complicated mechanism for producing nice-looking plots of data. I'm going to go through a series of examples of line charts and point charts and bar charts and pie charts. I'm not going to expect that you will remember any of these details, but you can use these as starting points for creating plots of your own. Okay, so to get going with matploilib, we need to first import NumPy so that we have a way of creating ND arrays. ND arrays is primarily the kind of thing that matploilib is happy to plot. So we will do that. And we're also going to import the pyplot sublibrary of the matploilib module. And the usual abbreviation that people use for that is PLT. So just like people use NP for NumPy and PD for pandas, we'll use PLT for matploilib. Here is an example. We are going to create, using arange, an ND array. Now in NumPy, a value for pi is defined as a data value. And with arange, remember that we give the starting point for the range, the ending point for the range, and here we can give a step size for the range. So we're going to start from minus pi, work our way up to just 1/10 less than pi at 0.1 intervals. Okay, now the Y ND array is going to be created from computing the sign of each of the items in the X ND array. So the Y ND array is going to be exactly the same length as the X ND array. And to get a line plot from matploilib, to get a line plot from matploilib, I can say plt.plot and then give my horizontal values and my vertical values, so my X and Y values. Now, if you're in Spider, this immediately produces a graph that you can see on your screen. I'm using idle, which, I recommend that you don't, but I am. And so for me, I'm also going to have to say plot.show to actually see the plot on the screen. So let me do this. I'm going to just do this manually. I'm going to import NumPy as NP. I'm going to import matploilib.pyplot as PLT. I'm going to get my X vector created, ND array, and p.arange minus np.py to plus np.py with a step size of 0.1. All right, so let me just show the first few values from X. I'll show the first 10 values from X. There we go. And then Y is simply going to be the vector sign of X. And so here are the first 10 values from Y. And now I'm going to say plot x versus y. plt.plot, not plot.plot. All right. plt.plot. And we get told, okay, a matploilib line chart was created. But to see it in idle, I have to say plot.show. And this will actually create a separate graphical window containing the plot. Okay, so there's the plot. Going from minus pi up to, but not quite including pi, at 0.1 intervals, I'm getting the sine of pi. Now, this looks like a fairly smooth curve. It's actually not. It's actually a sequence of line segments where the difference in the x's is just 0.1. If I exaggerate the step size, like by using a step size of 0.5 or a step size of 1, then I'll get a much less smooth-looking plot. Let me go ahead and do that. I'm using my same x and y. Oh no, I'm sorry, I'm not. I'm going to create x now. All right. Well, I'm going to stop fooling around with this. I've got this copied into a file. So let me so I don't have to manually type and waste a lot of time. Here is the same code creating the ND array X and the corresponding ND array Y, but this time using a step size of 0.5 rather than 0.1. And when I execute this code, I get a much choppier looking plot. And then, of course, if I carry this to an even more extreme case, I get an even choppier looking plot. Okay. So that's how to do a line chart. It's actually not very complicated. You create an ND array of the horizontal values and another ND array of the same number of corresponding vertical values, and just plot horizontal versus vertical, and you get that line chart. Now, the line chart is very plain at this point. There are no labels on anything except for the X and Y coordinates. No titles, no description of anything. I can use a variety of additional arguments to the plot function to specify things like line colors, line widths, line styles, etc. I can also execute commands directly to, or execute methods directly on the PLT library to set title, X label, Y label, and so on. Also, if I want to, and I'm not going to bother to show this, instead of displaying the plot onto the screen, I can save the plot into a PDF file. Let's take a look at this kind of thing, putting labels on things. Okay, so I'm going to use the same data that I did already for my sine of x plot. I've gone back to from minus pi to pi with a small step size of 0.1. Let's get the corresponding y values. This time I'm going to create a title, graph of sine, and an x label and a y label. That is the angle and the sine of the angle. for the X and Y labels. I'm also going to turn on a grid which is a light gray grid behind the plot, which hopefully will help me read approximate values for what the line is. And in addition to giving my X and Y end arrays, I'm going to say I want this to be a red line. I want it to be 3 pixels thick, and I want it to use dashes instead of a solid line. So with those enhancements, here we go, and wow. Okay, so you can see I've got my grid displayed, I've got my title, I've got my Y label, I've got my X label, and I've got this dashed, thick, red line. Okay. Okie doke. Now, let's suppose that you wanted to have names for the tick marks on the X dimension rather than just default values. I can do that by using the xticks method for the PLT, and I can do similarly for the yticks. Here is a more elaborate example. This time I'm showing the growth of bacteria, and I'm assuming that the bacterial growth is quadratic. So for each value of x here, going from -4 to 4 with a step size of 0.1, I'm going to compute the square of x. Now, bacterial growth, as is said here, is not quadratic. It's actually exponential, but an exponential plot will go flying off the top of the page pretty fast, so we're just going to pretend it's a parabola here. I'm also going to set the limits for the x dimension and y dimension that is going to be contained within the plot. Now notice that the values of x go from -4 to 4, or from -4 to 3.9. But I'm only going to display the part of that range from 0 to 3. So I'm actually leaving out over half of the x values. Furthermore, I'm restricting the range for the y values that are going to be displayed as well. I am going to display a grid, and instead of these numeric labels 0, 1, 2, 3, 4 and 0, 3, 6, 9, 12 for x and y, I'm going to display strings as labels. I'll have a blue line 2 pixels wide. Let us do that one. Okay, I'm going to uncomment this bacteria growth plot. Okay, we've got title, we've got X label, we've got Y label, we've got X values and Y values, restricted range of X values and Y values for the plot that's displayed. I am turning on the grid, and we're going to have names rather than numbers as our horizontal tick labels. All right, and poof. There we go. Okay. So, so an awful lot of work has gone into matploilib over a long period of time. And in fact, it was not originally developed for Python. It was originally developed in C++, I believe. But it's so high quality and so useful that it's been made available from within Python. Okay. Now, if you are using Spider, or another fancier integrated development environment as compared with idle, you can request the plots to be inline within any other, just in the same stream of output as your other, print functions and whatnot display. Or you can have what's called auto output, which will pop up this separate graphical window instead. And that's configurable in most integrated development environments. In idle, I'm stuck with this auto behavior. I don't have any mechanism in idle for requesting that I get my graphics actually in the shell's output stream. Here is, instead of a line chart, here is a scatter plot instead. And let me pull this code up. Okay, I'm going to re-comment that plot and display the scatter plot instead. So this is, I'm just going to create A range 12, so the X values are going from 0 to 11. And for the Y, I've just got 12, quote, random, unquote, integer values. I'm creating a scatter plot here with an asterisk as my marker, and I'm going to use a dark green color for each of the markers. So that's pretty straightforward. And there we go. Okay, so I've got my numerical X labels, my numerical Y labels, and the individual 12 points displayed. If I would rather have this data displayed as a line chart, then instead of scatter, I just go back to using plain old plot instead. And I can still specify that I want dark green as my line color. So let me pull that up. All right, so exactly the same data. The only difference that I'm really making here is instead of using scatter, for which I can specify a marker, here I'm just asking for a line plot and specifying the line color. And there we go. Okay, now we know how to create a title for the plot. We know how to create a Y label and an X label. We know how to modify the ticks, the tick labels, so that they are strings or the numbers. It's also possible for us to do what's called annotating the plot itself by putting some kind of label at some location within the plot area. And here I'm using annotate, and what I want to display within the plot area itself is this word mountains. These other two arguments, x, y, is the horizontal and vertical coordinates of where I want the beginning of that annotation to appear. And the interpretation for these x and y coordinates is axes fraction. What that means is that the x here, 0.2, is 2/10, 1/5 of the way along the horizontal axis. And you can see that mountains starts just a little before the 2, okay? So it starts 1/5 of the way along horizontally. And then 0.8 for the y, that means that it's 8/10 up from the bottom. Okay, and so that's where I get mountains to appear. Let's give that one a try. All right, so we'll try it this way, and then we'll change it so that you can see that I'm not lying. Okay, so here is my plot, and here is my annotation. Horizontally, the annotation starts a fifth of the way along. Vertically, the annotation starts 4/5 of the way up from the bottom of the plot. Now, if I change the location, let me have it just be 1/10 in the horizontal direction and only halfway up in the vertical direction. Try it again. And here we can see that we're closer to the left edge. We're only 1/10 of the way along horizontally, and we're halfway up vertically. Okay, so that's what the annotation is about. And you can have multiple annotations. Here I've established one annotation, but I can keep saying plot.annotate and put more things in if I wish. Now, here is a bar chart rather than a scatter plot or a line chart. The X and Y values being used are the same as the values that we've already used. All right, so our X values are going from 0 up to 11, and our Y values are these same, quote, random, unquote, numbers. But this time, I'm going to, first of all, use xticks to change the horizontal labels from 0 to 11 to January, February, March, April, May. These month, three-character month names. And I want blue bars. So I have a bar chart this time. And there we go. Okay, so I used xticks to change from numbers to names. And I asked for a bar chart with blue bars. It is possible to use longer names, which, if I just requested longer names and that was all I did, those longer names would write over each other. So I'd have January, and then February would overwrite the last part of January and actually the first part of March, and it would just look like a mess. But fortunately, when I use xticks, in addition to specifying that I want to use names rather than numbers, I can specify that I want those name strings to be rotated a certain amount. And here I'm specifying a 45-degree rotation for the names. And that will, at least in theory, cause the names not to overwrite each other and be set at 45 degrees. Now, in practice, that only works if your plot is big enough, and we'll see that. So this stuff isn't perfect, but it does the best it can. Let's run this guy. Okay, so here is my plot. I think it's... yeah, it'll fit in my video. But notice that the default size of the plot isn't wide enough at the bottom, so the bottommost letters here are sheared off. I can grab the top of this and drag and grow it. Whoop! I made it a little too tall there. To give more space for those longer strings. All right, so that's kind of a nuisance. As I say, it does the best it can, but it's got some imperfections. If I made this thing fill the whole page, which you won't be able to see the entire page, but if I made it fill the whole page, then there's plenty of room at the bottom for those for those names. All right, which you can't see. All right, and here is, surprise, surprise, a pie plot. Here I'm giving values. Notice that the values don't have to add up to 100 or whatever. You just give whatever values you want, and the pie plot will be built in such a way that the relative sizes match the values that you gave. I've got a title, and I've got labels for the sections of my pie plot. Okay, and I'll do that one. It's not really that exciting because when I run it for real, it just does what it's shown to do in the notes. Okay, but here we go. And there is my pie plot. Here is an example of a histogram. So this time we have vertical bars containing counts of the number of occurrences of some events. Rand N, you may or may not remember, produces a draw from a standard normal distribution. So in other words, mean 0 and standard deviation of 1. I'm specifying that I want to set up 25 bins horizontally to capture the counts of the values coming from these 1,000 draws. And so this gets me 1,000 random draws from standard normal and produces a histogram of them. Now, if I run this example, since I'm requesting random draws from normal, and the random number generator is typically initialized by default using the system's clock, I am going to get a nice-looking histogram, but it's not going to be exactly what we see on slide 19. It'll be close to, but not exact. Okay, so there's the one that I got, and in fact, each time we run this code, we're going to get a slightly different looking shape. And you know, the more iterations I ask for, the closer to a normal distribution that will actually look. All right, just out of curiosity, let's go up to 100,000. And there we go. Okay, so with 100,000 draws, I got a really nice symmetrical looking histogram. Okay. So we have line charts, we have scatter plots, we have bar charts, we have histograms, pie charts, and we can create box charts and tables and contour plots and on and on. You can also use a data frame to provide your X and Y information, for example. If I read in some data frame that has numerical columns, then here is a line chart of column 1 on the horizontal versus column 2 on the vertical. Okay. Here are even more examples. NumPy's linspace function is a little bit like arange. Here I'm getting values from 0 up to just shy of 20, and I'm getting them evenly distributed. I'm getting 1,000 draws within that range. I'm computing y as the sine and z as the cosine. And notice here that I can do multiple plots together in a single. I can plot multiple functions in a single plot. So this example is showing how to get two line plots in a single plot. And of course, in my case, using idle, I'll have to also say plot.show when I'm done. Whoops. So get rid of the histogram. Okay, so the red line is going to be the sine of x. The green line is going to be the cosine of x. And these are 90 degrees out of phase with each other. Okay, so the sine of 0 is 0. The cosine of 0 is 1. And so forth. So we've got a green cosine wave and a red sine wave. Whoops. So in addition to plotting multiple things, in this case 2 lines in the same plot, I could, by the way, have plotted a line and a scatter plot in the same plot. I can also create what's called a figure in which I can create an array of subplots. Okay, so I'm creating a 2x2 figure here, and I'm not going to go through all the details, but it allows me to create separate plots in the upper left quadrant and the upper right quadrant and the lower left quadrant and the lower right quadrant. Now here I'm actually only using upper left, upper right, and lower left. I'm leaving the lower right quadrant blank, and I'm producing a line chart, a scatter chart, and a bar chart into these into 3 of these 4 quadrants. The spacing isn't quite right here. I've got some text mashed on top of other text, so I need to do some more fuddling around to make things look pretty. In any case, there is an introduction, sort of a cookbook for doing things with plots using matploilib, and you can find a ton more cookbooks and examples online. But even just this limited stuff that we've shown is sufficient for doing some nice-looking plotting. Might be something worth adding, into your project if you have some stuff that would be natural for bar charts or histograms or line charts or what have you. Okay, take care. Bye.